Hello everyone, welcome back to another lecture on the course Python Fundamentals Building Blocks for Aspiring Developers. So we will continue with the seventh module in this one. According to our agenda, we are at the 27th day. Today we will learn about another concept which is inheritance. So let's begin. Inheritance is a powerful feature of the object-oriented programming. So what it does is that it allows us to create new classes. Those are like an extension of a previous class. Okay. So sometimes what we want to do is that we want to have a general class, let's say a general blueprint. Then we have something more specific. And we also want to create a blueprint of that specific thing. Okay. We want to model that specific thing. So instead of like creating everything from in the new blueprint in the new class, what we prefer is that we can extend that class. Okay, and based on that, we can use some functions from the parent class and some from the child class. So if we talk about the terminology, the parent class is the one that is at the top, and the child class inherits from the parent class. Okay, so this means that it is an extension of the parent class. Okay, so the parent class is also referred to as the superclass or the parent class, while the child class is also um, referred to as the subclass. Okay, so what it does is that it promotes code reusability and the concept of not repeating yourself. So you will see once we start doing this, and it also helps us to break down our code into more smaller blocks or combine them into some bigger general blocks. Okay, one example of this could be that you have a class called vehicle. Okay, so vehicle includes all the vehicles: bikes, cars, trucks, airplanes, helicopters, all the vehicles. Now, all the vehicles have a maker or the model who made the vehicle: Honda, Toyota, Suzuki, these kind of models. And it also has a, let's say, a color. But each of the vehicle has different number of wheels. The, let's say, a bicycle or a motorbike has two wheels, a car has four wheels, a truck, let's say, has 18 wheels, eight wheels, something like that. So what we do is that we create a general class that is about vehicles. Then we create a specific class that is a child class for each of the different vehicles. We create one child class for um, cars, another one for bikes, another one for trucks, and we can keep on creating as much as we want. So these child classes will inherit from the parent class that is vehicle. So what it will do is that it will allow the child classes to use the methods and attributes of the parent class. So this way what we are doing is that we are eliminating the same code. For example, all the vehicles have a color and a model. So instead of defining color and model as attributes in all four classes, which are car, bike, trucks, bicycle, we define these color and model in a parent class that is a more general class, and then we extend those in the child classes, which are car and truck, and in those we just simply say number of fields, but the other attributes are taken from the parent class. So you see how this allows us to avoid writing the same piece of code again and again. So this is the purpose of inheritance. So here is an example. So let's say we have a vehicle. It has a model and a brand. But let's say the car, we want to keep the color different. We want to keep the color separate. So we create the child class, which is called car, and it is inheriting from the class vehicle. So how do we represent inheritance? When we define a class, inside the parentheses we write the name of the parent class. Okay, now the parent class and the child class both have constructors, so we can when we create the object of this class car, since it is inheriting from this constructor also needs to be called. But this constructor is not called automatically in this child class. We have to call it ourselves. So how do we call it? Is that we either use the name, we say vehicle dot init, or there is a keyword called super. So super dot init will always call this constructor for the parent class of this particular class. We do not need to know the name of this parent class. So we do not need to remember, we can simply use super and call this, and this constructor will be called. So now this class can also use these methods, that is drive, but this honk method too. Now let's say if there is another object of this class vehicle, it cannot use the method honk because it is not of this class. It will only be able to use the method drive. Alright. Similar to this, we have my car, we create a car, then we say my car dot drive. We can use this one, we can also use this one. Okay, so this is the concept of how inheritance works, and this is a simple example. So there are different types of inheritance, that is single inheritance. One subclass inherits from one superclass. Multiple inheritance is that one subclass inherits from multiple superclasses. Like there are three or four parents, and then there is one, let's say, child. Then there is multi-level inheritance, that is, it kind of creates a chain. That one is a parent, then there is a child, then that child has another child, that child has another child. So this kind of creates a chain or a multi-level inheritance. And then we can also have hierarchical inheritance, where multiple subclasses inherit from the same superclass. We will have a look at some of these in the code. So let's begin. First, I'll open up VS Code, go back. So let's first create a superclass. So I'm going to say class vehicle, right? Like this. Now I'm going to define the constructor, and I'm going to say my vehicle class will have a color and a model. Okay. And I say self dot color is equals to color, and I say self dot model equals to model. Now you need to remember this is the attribute of the class, not this one. This is the value that we are using to initialize this attribute. Okay, I'm just keeping them the same name so it is easier for us to see. Now let's say def move. Okay, and we say and vehicle is moving, right? And now let's define a subclass or a child class. So we say class car, but since it is inheriting from this one, we say vehicle, and I'm just going to change this p here. For classes, it is a good practice to start with a capital letter, so this is why. So here I'm again going to define the constructor. So I'm going to say init, and then I'm going to say self, and vehicle will have what? Let's say tires, right? So we say self dot tires is equals to tires. Okay, now we say define. So car can move. What else can a car do? So let's say max speed, or in fact let's say a car can drift. Okay, self, and I say print, and I say car is drifting. Okay, but in this one what I need to do is that I also need to call this constructor for the superclass. Okay, so what I'm going to do is that I'm going to say super dot underscore underscore init. Again here I'm going to say self, and here I'm going to pass in the variable which is the color. So I say color and the model, and these are obtained from here. So I say color and the model of the car. So it's like we get them over here. So instead of using them here in this class, I pass them to the constructor of this superclass. Okay. Now I can create a object of car. So let's say car is equals to car, and in this one we need to give the constructor the values based on this constructor. Okay, so we need to say, okay, the color of the car is, let's say, red, and the model of the car is, let's say, Honda, and we also need to give the tires. So there are 4 tires, right? Now if I print it and I say print car dot tire, and the code says, okay, takes 3 positional arguments, but 4 were given. So let me get rid of this one. Okay, it's tires. It's not tire. I'm going to write this like this, and it says 4 because it has 4 tires. Now I can also access these things from this object car. Okay, because this class is an extension of this one. So I can also say color. Now it says the color is red. Okay. Now again, just to let you know, this is not a good practice to call the variables directly as we learned in the previous video, but just for demonstration, I'm going to do it like this. Now let's say we have another vehicle, which is not a car, but we do not know what that is. So let's say vehi vehicle is equals to vehicle. And since we are now initializing the vehicle, we do not need to give 3 parameters or 3 inputs. We need to give only 2. So we say the vehicle as a model, let's say Yamaha, and oops, as a color first. So let's say color is, yeah, yellow, and let's say Yamaha. Now what I can do is that I can say print vehicle dot color. Okay, but what I cannot do is that I cannot say vehicle dot tires. Okay, this line will show an error. So let me save it and run it. So what it does is that this is from the like the previous one. This yellow is we can access the color because this vehicle is an object of this class, but we cannot access this tires because this is not a part of this parent class. This is a part of the child class while our object is for the parent class. Okay, so we cannot access it, but the child can access the things of the parent class. So instead of color, we can also access the methods of the parent class. Okay, I will get rid of this one. So it says vehicle is moving. Okay, vehicle is moving from the parent class. Now let's say I also have another thing to model, that is bike, right? So what I'm going to say, okay, it inherits from the vehicle. It also have an um, constructor, and we say self cm, and we say tires, and we say self dot tires is equals to tires. Let's add one more attribute. So for bike, let's say we want to write sports or not. Is sport bike or is not a sport bike? Okay. So here I'm going to say sport, and here I'm going to say this. So this one is only in the bike. This attribute is not in the car. Okay. So what happens is that we have this general class. So both of these inherit from this class, which means that bike and car will have a model and a color, but the car will not have a attribute which tells if it is a sports bike or a sports car. It does not have this attribute. Only the bike has it. So you see, how we can use inheritance. So if I was not using inheritance, what I would do is that I would have to write this thing here as well as here. I will have to write this method here as well as here. So that's like a lot of repetition of code. The code is the same, but I just have to write it here if I was not using this inheritance. Since I am using this inheritance, I can write the common code in the common class based on the actual world entities, because vehicles have these things, and then I can get more specific in each of the child classes. Okay, so now what I'm going to say is that bike is equals to bike, and what a bike has, we say, okay, I missed one thing. I need to do this too. Okay, so what I say what my bike has, at first I need to give it the color. So let's say my bike is black. Then I need to give a, let's say, Honda. I'm just going to change this one to Toyota just so it is different and we can check it. Then we say the bike has two tires. Then we say, is it a sports bike? Let's say yes. Okay. So now, first for car, let's say print car dot color. And I'm going to say print car dot tires. Okay. Similarly for this one, I'm going to say bike uh, dot color. I'm going to print it. Then I'm going to say print bike dot tires. Then I'm also going to say print bike dot is sport, right? Run the code. So just let me just add a break over here. Next vehicle. So we have these two print statements showing this thing. Then we have this print statement showing this thing. Okay. So here you can see that this attribute is sport is not a part of car, so I do not want to include that in car. Okay, and I cannot even use that over here. If I try to do car dot is sport, it will show me an error. We can even try this one like this, and I say car dot is sport. Run the code. Simply says object has no attribute as sport. Okay, because it is not there. So this is the purpose of inheritance, that you can create a general class, then you can get more specific in each of the subclasses. Now, if we talk about some examples of inheritance, some types of inheritance, if I only had, if I did not have this class bike like this is just one child class inheriting from one parent class. So this is a single level inheritance. Now I have two child classes inheriting from one vehicle. So that is a hierarchical sort of inheritance. Then let's say if I had another uh, class, let's say I had class sports bike, okay, and I'm not going to write the complete body, but I just say bike, okay, and here I say the constructor, this, and whatever I want to write in here, whatever I write in here. So now what happens is that it has a child bike has a child sports bike. So this sports bike, so this kind of inheritance is called a multi-level inheritance. Okay. Now let's say if I have a vehicle, and also let's say class bike, or in fact, if I do it over here and I say vehicle and bike. So now this sports bike is inheriting from two classes. Instead of vehicle, let me say there's another class that is uh, new vehicle. Okay, let's say this is another class. Okay, so let me do this. So let's say this is another class. I'm not going to write the body just for demonstration purposes. So it's a new vehicle. So now this sports bike is inheriting from this one as well as this one. So it is inheriting from two parent classes. So this is now a multiple inheritance. Okay. So this is different types of inheritances. Okay. But after this one, you should get the concept of why we need to uh, you should get the concept of why we need to use inheritance in object-oriented programming. So that was all. In this lecture, we learned a new concept that is inheritance. So what again, I'm going to emphasize it that you do not need to become a master, or we do not expect you to become a master of object-oriented programming after this, even after this module, because this is a very vast field, very vast thing. But you need to know the concepts that are being used in object-oriented programming, so you can apply them or even understand them when you are doing programming or coding otherwise. Okay, so again, keep on working on these things, look at different examples, try to create your own use cases and examples, and then it will be much more familiar to you. Having said that, that is all for this lecture, and we will meet you in the next one. Until then, goodbye.